Hi everyone, and welcome to today's presentation. My name is David Bean and I'm the Solutions Manager for Mitsubishi Electric Automation Systems in the UK. What I'm going to do today is provide a brief overview of edge and cloud analytics and how they're applied in the manufacturing and utilities space. And in particular, I'll take a look at a couple of use cases, and also I'll probably present the argument that actually these are not mutually exclusive technologies, and indeed they do work in synergy and harmony together, and you'll see that through my presentation. So without further ado, let's move on to the presentation and we'll get started. Thank you very much. I'm going to start off my presentation today by just giving you a bit of an outline of what big data and cloud computing actually is. The concept behind this has been around for probably since the mid-2000s, and I think a great summary of what this actually means is that big data refers to large sets of data that are collected, while cloud computing refers to the mechanisms that remotely take this data and perform operations on that specified data. And I personally think there's been a slow adoption of this type of technology in the manufacturing space, and in particular in the SME manufacturers. And obviously that's despite its obvious benefits as well. But just to substantiate that claim, if we take a look at this particular slide here, which is from IBM, which looks at how big data and cloud computing is adopted both globally and in the manufacturing space, you can see that most enterprises find themselves sitting in this space here, where they're still exploring and developing a strategy to use this sort of technology to deliver benefit to the business. And I think there's probably many reasons why it has been slow to be adopted. And I've just illustrated that here with 3 particular points. And I think this is certainly true of many SME manufacturers. They'll say that we don't actually have the infrastructure in place to be able to deliver this sort of solution. You know, they have many dispersed assets on a manufacturing shop floor, which are not interconnected. They're not able to collect data from them. And then, or the other one, which I hear a lot, is, okay, we've got all this data. What are we actually going to do with it? What does it mean? How do we get this to deliver value? And where is the value in how we can use this to process this going forward? And the last one is, and I think we've certainly seen this over the past 2 years, and it's substantiated by a lot of statistics that have come from Make UK, is that they're concerned about cybersecurity and the opening up of their systems to the internet and what that actually means for them as a business. In conjunction, I think, with all this sort of idea around big data and cloud computing, I think there has been one technology that started to facilitate its growth over the past probably 2 to 3 years. And that's the concept of the industrial Internet of Things and also edge computing. I've just given you a bit of a definition here of what I actually mean by edge computing. So this is where we actually process and collect data on the periphery of a network or close to the asset under consideration as possible. And some of the key features of implementing edge solutions are around data aggregation and cleansing, and then using the aggregated data to be able to pass that on to cloud applications. And we can also look to do analytics at the edge, and I'll come on to that in a little bit more detail later in the presentation. And obviously what we're actually trying to achieve here, and some of the benefits of implementing edge solutions, is that we can actually get faster insights into the data that we've processed at the edge. And we can actually respond in real time to issues that are on the process. And obviously it's also improving our bandwidth as well. Now I've just got a couple of statistics here to illustrate how edge computing is certainly in growth mode. Here is some look at the industry, certainly over the period 2017 to 2024, and you can see a tenfold predicted increase in the growth of the edge computing market. And there's 2 particular sectors which have been key in picking up this sort of technology, and they are the sectors that we are particularly interested in at the moment, which are the industrial sector and the energy and utilities sectors. And I think some of this is around the fact that actually edge computing saves processing time, and it reduces the need for high bandwidth internet access that you typically would get with cloud computing systems. If we take a look at what we're doing here, and what we mustn't forget is that in collecting all this data, what is key is how we actually use it, how we analyze the data, how we then make meaningful decisions that are based upon that data to positively impact the performance of the process and the efficiency of the asset under consideration. So let's look at how we can apply this in a typical cloud computing setting. Here we have a typical process plant, in this case a sewage treatment works collected to cloud, and there are many different value-add services that we see operating in this space. Some of these you may be familiar with, such as predictive maintenance and asset performance around OEE as an example. But there are some distinct disadvantages to this type of solution, and I've identified these here, and the one I'll just illustrate is that around high cost. As you begin to pull more and more data off the plant and do more and more analysis of that data in the cloud, you impact two specific variables, those being cost around the charges made per data point and also the charges made for compute power. And so the costs can escalate quite significantly over time as you begin to use these sort of systems more and more. Mitsubishi Electric itself does have solutions that play in this space. Our hardware platforms definitely sit in the underpinning our Iconics dashboards in the cloud, based in Microsoft Azure, for actually presenting the data back to the operators. So we do have solutions that sit in this space, but then how do we implement Edge to facilitate a quick win in terms of analysis of data and reducing the cost of sending data to the cloud? If we take a look now at this in particular, and when we start to insert the edge systems into the process, we can bring down some of those particular areas or solution areas that we can then use to analyze the data, especially around analytics, which can provide predictive maintenance data, or optimization, which can then provide closed loop control back onto the plant. But we don't forget the cloud-based applications. They also integrate into this sort of solution, where we can aggregate and cleanse the data and send a limited amount to the cloud, which can be used for solutions such as scheduling and supply chain management and activities like that. And what we're trying to do is distribute the analysis between edge and cloud in order to be able to maximize productivity and reduce cost. And I think there are some specific areas where we can get quick wins for this sort of concept, where we're developing the analytics at the edge. And there are three key areas that I'd like us to consider. These are predictive and prescriptive maintenance, energy demand side management, which is becoming more key as we as a country, and in fact globally, look to hit carbon net zero by 2050. And finally, process optimization and the use of digital twins. I'll take each of these in turn and just give you a use case for each of them before summarizing this presentation. In terms of asset maintenance and predictive maintenance, there has definitely been a complete evolution of this particular space over the last 5 to 10 years, where we've moved from sort of reactive maintenance regimes, and with now the availability of all the data and analysis of that data through systems such as Edge and Cloud, we can move into predictive and prescriptive maintenance techniques in order to be able to optimize assets on the process floor. And I've got an example here of actually doing that, where we're looking at gear wear analytics. So there's a whole host of variables that actually operate on that gear, and in fact indeed impact the performance of that gear over time. And obviously what we're trying to hit is this point here, or trying to be able to analyze and find this point here, where a changing one or several of those variables, or a combination of them, start to show a decay, or the point at which the asset life starts to decay. And that's the point that we're looking for, to be able to predict that point. And if you look at Mitsubishi Electric solutions that sit in this space, we have a product that sits on our edge platform, which is called RealTime Data Analyzer. And this enables us to take data off the shop floor and analyze it in not in real time, just taking the data from the shop floor, analyzing it, looking for those variables that make a difference to the performance or health of the asset. We can then use that to create a diagnostic rule or a series of diagnostic rules that we then apply back to the edge platform when it's in real-time operating mode to actually manipulate and operate on the data that's collected, analyze it, compare it to the diagnostic rule, and then feedback or flash up if there is an issue with the plant, or it looks like the particular aspect of the plant is going to fail at some point in the future. We can even start to apply AI to the process as well, and actually start to have some sort of closed loop control here, where the AI is taking a look at the data and is then starting to feedback to change the performance of the plant in order to extend the operation of the asset under consideration, to extend its lifetime as much as possible, without actually impacting or impeding the performance of the underpinning operations. Where has this been applied? We've certainly made use of this in the water sector. And here's an example of some Archimedes screw pumps on a particular sort of unmanned site, where they did have a preventative maintenance regime, and they were still having failures, and it was still causing significant amounts of downtime on site. By moving to predictive maintenance, cloud-based predictive maintenance, they've been able to flag up where the issues occur in advance and then be able to plan for replacement of worn gears, etc., as and when needed, without any sort of downtime. One of the other aspects of using data in the cloud and also in edge platforms, and what we can actually do with that data, is we can start to develop models of the plant itself, and these are typically called digital twins. We've actually had many applications where we've used digital twins, and specifically in the water industry, where we've seen a great opportunity to use these for aeration plants in sewage treatment works. Obviously, in the aeration plant, there are many factors that affect the performance of the plant, such as dissolved oxygen levels, pH, the weather itself, and we can use analytics and the digital twin or the model of that aeration process that we've built to take those real-time variables into the model and therefore be able to manipulate the real plant to ensure that it's performing optimally. And we've certainly made use of that in aeration plants in the water industry. We've also got an opportunity here, or a system here, that we've developed for Alstom, which is actually on a paper mill. So again, we're collecting data from many different systems that underpin the ecosystem of that paper mill. We're collecting data at the edge, and therefore reducing the amount of data that's actually going up to the cloud, where the decision making is actually made around energy management. And I've got some examples here of the dashboards that are used on this particular application, where we can actually use the digital twin to be able to predict energy usage against production over a period of time. And also we can actually build into that downtime as well. So if we've got planned downtime into that activity, again, we can use that to predict energy consumption, and therefore enabling the plant to be able to make sure that it's on the best tariffs with their energy provider, or even look to supply energy back to the grid when they can, in the case of using demand side response. So in summary, just to sort of finish off my presentation today, I'd just like to say that analytics is key. You know, the interpretation of data and using it to make meaningful decisions that deliver value to the business. And in fact, the edge and cloud are not mutually exclusive, that they do come together, and there is a synergy between them that really have made or facilitated the outputs from cloud-based systems and reduce the cost of them as well. We've seen some particular use cases around condition monitoring for predictive maintenance, and also for energy management on things like the paper mill that I showed you there. One of the things we must remember in actually exposing all this data, especially to the internet, is that we've increased the attack surfaces from a cyber security perspective. And so it is necessary to start to think about the security needs on our plants. And there are standards, in fact, to do that, such as IEC 62443. Okay, so on that note, that really ends my presentation for today. So thank you for listening.